In this tutorial, we shall discuss how to solve a two-way ANOVA problem manually. Since using of calculator is common, I have avoided the shortcut method and used the direct method. The solution to this problem in PDF form is available with me. Those who want to have a copy of it shall contact me using my email ID, which you can find in the description. Well, this is the problem we are going to solve today. 5 types of fertilizers are applied to 4 varieties of potatoes, each planted on 5 plats of land of same size and fertility. The yields in quintals are shown in the following table. Types of fertilizers are shown along the column, varieties of potatoes along the rows. First type fertilizer 34, 50, 42, 38. Second type 38, 38, 36, 44. Third type 44, 46, 50, 52. Fourth type 40, 52, 46, 36. Fifth type 42, 44, 48, 42. Test at 0.05 level whether 1. The effect of fertilizers and 2. The effect of potato varieties are significant on the yield of potatoes. Let us start the calculations. First, develop an empty table like this. The space within each cell must be large enough to contain the calculated values. Enter the given values along with the labels for columns and rows. For identification purpose, we shall refer this table as Table 1. After leaving sufficient space, develop one more empty table like this. For identification, we shall refer this as Table 2. Table 2 is going to contain the squared x values of Table 1. Let us square each x value in Table 1 and place them in the corresponding cells. At last, we sum up all the x squared values and place it at the right bottom corner cell. It is 37,724. Symbolically, it must be understood as sigma x squared equal to 37,724. Let us move to Table 1. Find the total number of observations, capital N. It is 20. Find the number of observations in a column, that is nx. It is 4. Calculate the column total Tx. They are 164, 156, 192, 174 and 176. Then calculate the grand total sigma t. It is 862. Calculate square of column total, that is Tx squared. They are 26,896, 24,336, 36,864, 30,276 and 30,976. Calculate its grand total sigma Tx squared. It is 1,49,348. Now we shall deal with rows. Find the number of observations in each row, that is ny. It is 5. Calculate the total of each row, ty, and place it in the appropriate cell. They are 198, 230, 222 and 212. Then calculate the grand total, that is sigma t. It is also 862. For your kind information, sigma tx equal to sigma ty. So we mean it as sigma t. Moreover, it is total of all the x values inside the table 1. Calculate square of these total, ty square. They are 39,204, 52,900, 49,284 and 44,944. Calculate its grand total, sigma ty squared. It is 1,86,332. Let us state the hypothesis. As we have to test the mean yield of fertilizers and potatoes, we have two hypotheses here. Hypothesis 1. Null hypothesis. There is no significant difference in the mean yield due to fertilizer. Alternate hypothesis. There is significant difference in the mean yield due to fertilizer. Hypothesis 2. Null hypothesis. There is no significant difference in the mean yield due to potato variety. Alternate hypothesis. There is significant difference in the mean yield due to potato variety. Before I start the main calculations, let me state the key values so that we need not shuttle between pages. Total number of observations, capital N 20. Number of observations in a column, that is Nx 4. Number of observations in a row, that is Ny 5. Sum of all observations, sigma t 862. Sum of the square of all the x values, that is x squared equal to 37,724. Sum of the tx values, that is sigma tx squared 1,49,348. Sum of the ty values, that is sigma ty squared 1,86,332. Let us begin our main calculations. Calculate the correction factor first. Correction factor CF equal to sigma t squared divided by capital N. 862 square by 20. On simplifying, we get 37,152.2. Let me post this value also along with the key values. Calculate the total sum of squares, that is SST. SST equal to sigma capital X squared minus correction factor equal to 37,724 minus 37,152.2, 571.8. Calculate sum of squares of column values. SSC. SSC equal to sigma tx squared by nx minus correction factor 1,49,348 divided by 4 minus 37,152.2. On simplifying, we get 184.8. Calculate sum of squares of row values, SSR. SSR equal to sigma ty squared divided by ny minus correction factor 1,86,332 divided by 5 minus 37,152.2. On simplifying, we get 114.2. Finally, we shall calculate error or residue, that is SSE. SSE equal to SST minus within bracket SSC plus SSR equal to 571.8 minus within bracket 148.8 plus 114.2, that is 272.8. Now it is time to form ANOVA table. In the first column, we have presented the sources. They are fertilizer, potato, error or residue. Error or residue can also be understood as unexplained variations. It means fertilizers and potatoes are explained variations. As the last item, we have shown the total. It is the combined effect of explained and unexplained variations. In the second column, we represented the sum of squares. Column sum of squares is 184.8. Row sum of squares is 114.2. Error or residue is 272.8. Total sum of squares is 571.8. In the third column, we displayed the degrees of freedom. Degrees of freedom of SSC is C minus 1, that is 5 minus 1, 4. Degrees of freedom of SSR is R minus 1, that is 4 minus 1, 3. Degrees of freedom of SSE is C minus 1 into R minus 1, that is 5 minus 1 into 4 minus 1, 12. Degrees of freedom of SST is capital N minus 1, that is 20 minus 1, 19. In the fourth column, we have stated the mean squares. Mean square of column is SSC divided by degrees of freedom, 184.8 divided by 4, 46.2. Mean square of row is SSR by degrees of freedom, 114.2 divided by 3, 38.1. Mean square of error is SSE by degrees of freedom, 272.8 divided by 12, 22.7. In the fifth column, we have shown the F ratio or calculated F value. F ratio for fertilizer is MSC divided by MSE. 46.2 divided by 22.7, 2.03. F ratio of potato is MSR divided by MSE, 38.1 divided by 22.7, 1.68. In the last column, F critical value or table F value is shown. Critical F value corresponding to MSC is 3.26 and that of MSR is 3.49. We shall turn our attention to the steps involved in finding the table value. We are going to test the hypothesis at 0.05 level of significance. So let us use the F distribution table meant for 0.05 level of significance. I have given the relevant part of the table. First, let us find the F value for MSC. Its numerator degrees of freedom is 4. Move horizontally to 4. Its denominator degrees of freedom is 12. Move down vertically to 12. Then move down vertically from 4 and move horizontally from 12. The meeting point determines the F critical value. It is 3.26. This value is already displayed in the table. Conclusion. In this case, the calculated F value 2.03 is less than the table value 3.26. Null hypothesis is accepted. There is no significant difference in the mean yield due to fertilizers. Inference. The quality of all fertilizers are the same. Now we shall find the table F value for MSR. Its numerator degrees of freedom is 3. Move horizontally to 3. Its denominator degrees of freedom is 12. Move down vertically to 12. Then move down vertically from 3 and move horizontally from 12. The meeting point determines the F critical value. It is 3.49. This value is also already displayed in the table. Conclusion. In this case, the calculated F value 1.68 is less than the table F value 3.49. Null hypothesis is accepted. There is no significant difference in the mean yield due to varieties of potato. Inference. The quality of all varieties of potato are the same. Well, our discussion ends here. We shall meet in its Tamil version.